Before you watch this video, you should already have all of your equations copied into your journal. If you do not have your equations written down, stop this video, go back, and copy your equations. That's all we're going to talk about in this video. You're going to need colored pencils, blue, green, red, and orange, preferably pencils because you're going to be shading over some of your writing. You can also trace over your writing with colored pens if you prefer. So as I said, you should already have all of your equations written down. And some of these may look a little different, things that you're not used to. So let's talk about them before we get started with the color coding. Let's start with the very first equation, A equals delta V over delta T. Hopefully you remember that delta means a change. And when we look at the change in any variable, we look at the final minus the initial. And so we can write our equation delta V over delta T, or we can write VF minus VI over our T, our time. VF means velocity final. VI is velocity initial. So it's just a fancy way of writing what we've been talking about this whole time. Final minus initial. So acceleration is equal to the change in velocity divided by the change in time. And you're going to see that in several places, mostly with VF, VI, but you'll also see things like DF and DI, the displacement. What was the final minus what was the initial? This is what we did when we found the slopes for our velocity graphs. You're going to see a lot of squared in these equations. That's very important. And make sure that you are applying the square to only the variable that it's written on. You'll also see several that have a square root. Remember when taking the square root to take the square root of the entire value underneath. So for example, t equals square root of 2 times d over a. Do the whole part underneath first, 2d over a, and then take the square root of that entire thing. These are really common mistakes that students make. Now let's get to color coding. The color coding is very, very easy. Each variable has a specific color that has been assigned to it. If you color coded your equations on the scalars and vectors notes, then you've already got a head start on that. We're going to start with A. Acceleration is going to be color coded in orange. So anywhere in those equations that you see the letter A, you're going to shade it orange or trace over it in orange, but orange is our key color here. Notice that not every equation has an A, and that's all right. Next is V. Velocity is blue. There's a lot of those. Make sure that you are also tracing over or shading over the F and the squared, because that's part of it as well. It's an important distinction. Are we talking about average velocity, final velocity, initial velocity? Are we squaring it? Those are all important pieces. Next is time. Time is color-coded in green. Again, notice that not all of the equations have a t in them. And finally, D. Displacement is color-coded in red. Hopefully this will help you use these equations. When you're trying to solve a problem, there's a process that you need to go through, and we'll talk about that some tomorrow. But it's very important to understand which variables are included in which equation. So you know, for example, let's say you're trying to find final velocity. If you have initial velocity and acceleration and time, you can use this equation. If you're missing any one of these three pieces, you can't use this equation and you have to find a different equation to use. So color coding can be very helpful in figuring out which is the best equation for you to use in any circumstance. You might have more information than you need. You might have enough information to use any one of these three equations for final velocity. In that case, just pick whichever one you prefer. But most of the time, you're going to have to pick your equation based on the information that's given to you in the problem.